Okay, this is Math 31, Section 3.3, examples of solving linear equations with only one variable at a time. Okay, in example A here, what we have is variables on both sides of the equation. And before we can simplify that, we have to gather those variables on one side and the constant numbers on the other side. So let me show you what we have to group. We have to get the 9x and the 10x on the same side of the problem. And we have to do the same thing with this negative 12 and this negative 4. And before that happens, you can't do any more simplifying. So the first step here is to rearrange. And you can see that I took the 10x over to the other side. And when you take it to the other side of the equal sign, you have to change the sign. So it's now a negative 10x. And likewise, you're going to do the same thing with the negative 12. And take it over to the other side as a positive 12 or a plus 12. Now what's really happening here in the background is that you're adding 12 to both sides on that last step. Okay, then you just simplify both sides. You can see that I get negative 1x on the left and 8 on the right. And finally, you're going to divide both sides by negative 1 to finish the job. Okay, on example B, we have a multiplication on the outside of a parenthesis, which means that we have to distribute before we do anything else. So we're going to distribute. That's the first step if it's required. You can see that I multiplied 4 times the 3n and 4 times the 5. Next, you're going to gather your like terms on one side. We just did that on the previous problem. You can see that the two terms that switch sides also change from positive to negative in this case. And then you simplify both sides. So for instance, on the right, 20 minus 2 will give 18. The left side, 6n minus 12n is negative 6n. And finally, you divide both sides by negative 6. And that has the effect of canceling off the left-hand side there. A little bit too thick a tool there, so let me fix that right away. Anyway, if you cancel off the negative 6's, you get n equals negative 3. Okay, two more examples of this. This example C does have two places where we have to distribute, so that'll be the first step. You can see that I multiplied, for instance, on the right-hand side, 7 times p and then 7 times 4. The next step would be to gather our like terms, so you're going to see me moving stuff from one side of the equation to the other. And don't forget when you do that to change the sign of the ones that move. And then you simplify both sides. For instance, 6p minus 7p gives negative 1p. And then you divide both sides by whatever's in front of the variable. And that'll take you down to an answer of negative 46. Okay, example D, we have 34 minus the quantity 3t minus 4. And the trickiest part is distributing that negative sign. So you're going to see me doing that first. I'll distribute the negative sign. So for instance, negative times 3t would give negative 3t. And the opposite of negative 4, the second half of that, gives positive 4. Okay, now we got to get all our variables on the left-hand side and everything else on the right-hand side. So you can see stuff moving from one side to the other. Good time for me to kind of highlight something here. The 8 is still on the right-hand side of the equation, so it's still 8. But for something that moves, for instance, this 4, from one side of the equation to the other, you have to change the sign when you do that. And if you subtract 4 from both sides, you'll get the same result. This is just a shortcut. Okay, next you'll simplify the left and simplify the right. And then to finish this off, you'll have to divide both sides by negative 5. Okay, so in the next section, what we're supposed to do is write the sentence that's described. Okay, so the mathematical version of it instead of the verbal version. And I'm going to start with a division. It says quotient. So we're dividing something here, two things. In this case, negative 14 is being divided by 2. And let me highlight what I've done so far. The quotient of negative 14 and 2. And then when it says yields, that means equals negative 7. And that's true. Whether it's true or false, we're actually just trying to translate it into the symbols instead of the words. Okay, next we're going to take 9 times the difference. Well, difference means subtraction, so we're actually subtracting two things. And let me highlight those things. Negative 2, and we're subtracting 6. So let's do that first. Negative 2, and we're subtracting 6. And that whole amount is supposed to be multiplied by 9. 9 times that difference. The word is translates into an equal sign. Negative 72. Okay, the last one in this section, at least the last example, is 11 subtracted from negative 9. This is a reverse subtraction. 11 has to go behind the subtraction. Equals negative 20. All right, examples H and I refer to this bar chart over here, bar graph. And in the bar graph, what we have is the population of largemouth bass in Baton Lake. The numbers are representing thousands. So we have to keep that in mind. It says in thousands. All right, the first example is how many largemouth bass were present, or what was the population in the lake in 1990, and you see the number 84 at the top there. You can also guess a little bit at it, but the scale is on the side. You're better off using the numbers that are there. Anyway, that says 84, but that's really 84,000. 84,000 largemouth bass. Okay, example I wants to know the amount of decrease from 1995 to from 90 to 95. In other words, how many fewer largemouth bass were there between those 2 years. So take the larger amount and subtract the smaller amount. And that gives 12, but once again, this is actually 12,000 fewer fish is how you interpret that. Now, it looks like the population of fish recovers in the subsequent years, so maybe they realized that year that they had to do something to fix some of the population troubles for the largemouth bass in that lake. Okay, on example J, what we're going to do here is substitute the values that are given to us for X, Y, and Z, and then use the order of operations to take it from there. So the first thing to do is where it says Z, you're going to put a 6. Wherever it says Y, you're going to put the negative 3, and wherever it says X, you're going to put the 0. So now you're going to try and figure out how much this adds up to, or what the result is of all these calculations. And order of operations says you pay attention to exponents next. So I did those exponents. You can see negative 3 times negative 3 gives 9. And then negative 3 times negative 3 times negative 3 ends up being, if you think of it this way, 9 we just did times negative 3 gives negative 27. Okay, then from there, you do the multiplication before the adding and subtracting. And finally, let's do this off to the side here. 54 take away 27 is 27. So the final answer is 27. Okay, the last section of this homework is really all about finding mistakes and fixing them. That's not always easy to do. I'll point out a couple places where this person doing this problem made a mistake here. Looks like they distributed correctly here to get the first two terms, but then they got over enthusiastic and they multiplied this one by -7 also, so that's a mistake. And down here, they multiplied across here and got -6x. That's fine. But they forgot to multiply it here. In other words, they didn't distribute. And there's another mistake. Now, from now on, all this is kind of garbage, but you can see maybe that 10 minus 2 would give 8, not 12. So there's all sorts of problems here. And so we're going to try and fix this. So you can see I've copied the original. That's what you should do. And we're going to first distribute correctly. And then we're going to simplify a little bit. So for instance, the 42 minus 4 gives 38. And then once you've done that, now you're going to take all your variables to the left-hand side and all your constant numbers to the other side. Remember to change the sign of the numbers when you take them to the other side. Then you simplify both sides and divide by -1. And the correct version is shown on the right there. Okay, so this ends the section 3.3. You got quite a bit of practice here of solving equations with variables on both sides of the equation. And you also learned in this section that you have to distribute if that step is needed. That's the first thing you should do on these problems.